So with regards to covalent compounds, you want to be able to explain the difference between covalent molecules and covalent networks. So starting off with covalent molecules, I have drawn an example here of carbon dioxide. So you have your carbon atoms, double bonded to an oxygen atom on either side. Now remember, these covalent bonds happen because the carbon and oxygen atom are unstable, and therefore they share electrons to have a stable electron arrangement. The bond is held together by the attraction of the nucleus, which is positive, for the shared pair of negative electrons. That's what holds it together. Those covalent bonds are incredibly strong. Those are represented by the blue lines on my diagram. But you'll see there's also some little purple dots. Now these purple dots exist between the molecules, not inside. Inside is where we find the very strong covalent bonds, but between the molecules is where we find these weak intermolecular forces of attraction, they are called. Now, when we melt or boil a substance, it is not the bonds on the inside that are breaking. It is these bonds between the molecules, in other words, the intermolecular forces. So if these are very, very weak, then that means not very much energy is required to melt or boil these covalent molecules. They are held together very, very weakly, and so a little bit of energy, so for example, some of them don't even have to get to room temperature. They've already melted or boiled by then. That's enough energy to break these purple intermolecular forces. The strong covalent bonds are not being broken in this instance. This is a note that I'd like you to copy as well, please, and try your very, very best to copy the diagram if you can see it clearly enough. So covalent molecular substances have low melting and boiling points, and it's due to those only weak forces of attraction being broken when they are melted or boiled. Giant covalent networks are different. They have strong covalent bonds throughout the entire structure. So they are just one big giant network of strong covalent bonds. If you try to melt or boil these, then it's the covalent bonds that must be broken, and they are so strong that it takes lots and lots and lots of energy to do this. That's why their melting points are thousands of degrees Celsius, because it requires so much energy to break these strong covalent bonds. Again, that's another note I'd like you to copy. Try your best to draw the diagrams. You do need to know what these structures represent. This one here in the middle is carbon in the form of graphite. It's a little bit different. It has layers. But if you wanted to copy this one, the blue one here, that would be absolutely fine. So I've got two examples here. Basically, I'm going to talk you through each example, and I want you to tell me what kind of covalent compound it is. Is it a covalent molecule, or is it the network? Which one is which? So this is silicon dioxide, often called silica. It's extremely sturdy. It's used in the manufacture of buildings. It's in concrete. It's holding things together. It's extremely, extremely tough. Its melting point is 1670 degrees Celsius, and it's a solid at room temperature. You can see its structure here. I've just put in a wee picture of sand as well. So what is that? Is that a covalent network, or is that a covalent molecule? Example 2. Bromine is a liquid at room temperature. It melts from solid to liquid at -7 degrees and boils into a gas at 59 degrees Celsius. Its main use is as a flame retardant for plastics, but it's used in water purifications like another halogen that we know, chlorine. So I've given you a wee diagram of bromine here as well, with intermolecular forces showing on that. So what I'd like to do, which example is the network and which one is the molecule? If you can answer that, then you can identify the type of bonding present by looking at the properties of a substance. And that was what we set out to do today. So very, very well done.